Okay, we got a bunch of parts in, so we're going to start chipping away at this thing today. So first board we're going to start at is this power supply board here in the back. So to get at the components, I have to undo the screws. So we'll just undo these. Okay, so screws are out. Now you can just flip your board over. The wires are probably going to be a bit fragile, so don't really yank on it. Just try to lightly bend them. They've probably been in this position for, I don't know, 50, 55 years since the unit's been built. Everything on this board looks original. What we're going to start with is replacing the diodes. So we have 1, 2, 3, 4 right here, as well as an additional 2 kind of hiding up here. So I'm going to be using these big 1N 5404s to replace these. Right now they're fine on this unit, but just given my past experience with these diodes, they're coming out. We'll also replace all the caps on the board, as well as the 3 transistors. Okay, so let me get everything set up and we can get going on this. Okay, so we got the components on the bottom pre-marked. You can see little black marks here and there where I marked out the component locations on the underside. So working on these older receivers, you want to be pretty gentle to the boards. The traces tend to pull up pretty easily, just due to the age and maybe even just the design at the time. Pretty early circuit boards, so probably didn't have it quite figured out yet. I do have a tool that's sort of like an iron that you can kind of press against it, and it has a button. You can suck the solder up. Unfortunately, it has quite a big hole, probably similar to something like this. So it's on these Pioneer units, all the leads are bent over when they install them, so it's tough to really get a good good heating on a lot of the solder under the lead. So got a couple other options. So you kind of have your really cheapo solder sucker. I found this doesn't work great on these, just due to, again, kind of the larger suction hole. It just doesn't really do a good job of getting the stuff up. Solder wick, this stuff I find works very well, but the downside is it's expendable and not the cheapest. And I just got this newer solder sucker. Tried it out on some smaller other projects. It seemed to work very well, so we're going to go with this and hope it does the job. If not, can always switch back to the solder wick. Okay, so start off here. So all you have to do is apply heat to the location of the joint and just try and remove as much of the solder as you can. Only weakness on this is every time you have to kind of empty it. And on these boards, it's tough to get a good press on it. Okay, so you should understand the process. I'll kind of do this off video for a little bit and check back in a few minutes. Okay, we're back on the last one of those four diodes there, so figured I'd try to give a close-up view of what I've been doing. It's going to be tough to reach down on the camera, but basically apply the heat. You can see they do have a ton of solder on the tracks. Hit it with this thing a few times, and then most of the leads have been free enough to give a little wiggle, and they come loose. So just apply the heat and get the solder to start melting. Okay, so you can see that first shot took off a good little top layer there. Let's see if we can just apply a little heat and get this thing wiggling loose, and you can just see it loosened up there. Okay, so that lead's pretty free. Now we're going to move on to the bottom lead here. Oops, and the sucker plunger just smashed the camera there, so sorry about that shaking. Okay, and see if we can get this one shaken loose with a little heat. Okay, not quite yet. So have to hit it with the sucker a few more times, but a little tough to work around the camera, so just pause the video here. Okay, I found the issue and I mismarked the board, so that was why that diode didn't want to come loose. So now that I know the proper lead I want to grab, I'll just try and do that. There we go. So you can see how the leads here are shaking. So that's how you know it's good and loose. Now to pull these out, you can just take your pair of micro cutters or needle nose pliers and just grab the end of the lead and bend it straight. And same for this guy. Okay, so this one's nice and loose. That one's looking good. That one looks fine. Okay, and a note, if it's still attached by solder and you're trying to pull up with the micro cutters or micro shears, whatever you'd like to call them, you do run the risk of pulling out part of the trace. So if you're gonna do it, make sure the leads are already loose. If you can't get a lead up, again, it's the best way to probably do it is just apply some heat to the lead and the trace and just try to work it back and forth. That way the solder heats up and comes loose, and as you're, even when you pull the iron away, you keep working it so that way the solder doesn't settle a good connection again, and so the leads are loose. Okay, so I'm going to replace these one at a time just so I know which end goes where. So got this neat little turntable thing underneath the receiver. Just got it offline, so hopefully it'll help me work a little more efficiently here, instead of having to reach around and pick the receiver up. Just can give it a spin. Okay, so let me get my new diodes and we'll be right back. Okay, so got some the replacement diodes for these. So just going to start pulling them out. So these ones are not marked anode and cathode, at least obviously that I can see. Oh, strike that. So it's not like a newer diode like this guy where you're got the kind of silver gray band. See if the camera will focus in. You should be able to see kind of the diode symbol there with the anode and cathode. Okay, so these don't want to come out, so I'm just gonna snip the leg a little bit on the back side to get them free. Okay, so hopefully you can, let this focus in. Yeah, so hopefully you can see that kind of in the light there. And then of course on the board, you got the markings, so when you're replacing them, you want your band to line up with the line, so this end's going up. So kind of funny to note. So these are the SW1s, which are called out for in the manual. But on the last one of these I did, I believe the diodes in there were FR2s. Maybe these SW1s are better quality. Not really sure. I'll have to compare the serial numbers, see if one was an earlier or later model or manufacture date. So just gonna bend the leads on this and get it installed. So no real magic behind it, just kind of bending it with my fingers. Looks like, I guess, pretty good. A little closer. Okay, so it looks like there's a little bit of solder buildup on this lower through hole. So what we're going to do is just apply heat to the back of the board, and this thing should slide right in once my iron heats up. And I guess something important to note is never trust the screen printing on these boards. There are receivers that are noted for having incorrect screen printing. I don't believe this is one of them, but as you pull a component, make a mental note or write it down or take a picture just so you know the way configuration of what you just pulled out was in. Because if this was backwards here compared to how it's really supposed to be installed, then you're going to be chasing your tail trying to figure out what's going wrong when you turn it on and it doesn't work. Okay, so get that in pretty good. So just going to go through kind of doing the same process here with the rest of these. Check back in once they're all done. Okay, so we got all four swapped out. So just going to tack these in place. So again, nothing too crazy. Just heat the lead, heat the pad. On these ones, the leads are pretty chunky, as you can see. So you want to really apply some heat there to make sure the lead heats to take the solder. So we'll start from the inside and work our way out. So what I'm doing is just tacking in the lower leads for now. Good practice when soldering is that you want to clip the lead before you solder it. So I'm going to, now that they're tacked in, just go through and clip both sets of leads and everything, and then kind of do the final soldering. So just good practice to avoid corrosion once you snip it. Instead of the tin on the outside of the lead, you got kind of the copper inners typically. So yeah, just to avoid corrosion kind of traveling up that copper, just cover it up with solder. Yeah. So we'll say soldering is a lot easier when you're using good stuff. The lead-free tends to not work the best, I'll say. So just use a good brand name. I use Kester Rosin Core. Just makes life a lot easier. Okay, and then to touch up these lower ones again. Okay, these ones should be good to go. Okay, so we got those four kind of main diodes. I think those four made up the kind of the rectifier. Wow, I can't talk today. So next I'm going to try and get these two. Then we'll follow up with the caps and transistors. So again, with these two, won't be anything different than replacing these top four. Something to note is if you want to use kind of these bigger diodes down in these two, the legs are, or the leads are a bit thick for the through holes. So You either have to try to upsize the through holes a little bit, or you can try and trim down the legs a little thinner to get them to slide through easier. Okay, so I'll get those two done and in there, and we can kind of move on to the rest of the board. Okay, so we got all our diodes replaced. I did end up using some smaller diodes here in the back, some 1N4007s, and of course our bigger diodes up here. So just to make sure I didn't screw anything up, got it hooked up to the dim bulb. So we'll fire it up and see if it works. Okay, power's on. Dim bulb isn't, or dim bulb's still dim. Let's go to FM. It looks pretty strong. Okay, definitely getting sound out of both channels. So diode replacement is done. Next, we'll move on to the cap and transistors on this board before jumping on to the next couple boards here. Okay, we're going to do the transistors on this board next. So we got 3, one here, and then another 2. Transistors are kind of my least favorite thing to replace. Just making sure you get the pin out right going back in. When I pull them, I use this little component tester here just to check the pin out to make sure it matches what's on the board. And also, prior to pulling anything out, I take about 1,000 pictures of the board to make sure I have record of how everything was oriented. That way, if I forget what it looked like before I pulled it, I have something to reference back to for ensuring that the that pin out was correct. So, not gonna bore you with having to watch me unsolder these components. Just go ahead and do that. Once I get them loose, I'll show how this little component tester works and how to make sure you get the pin out right going back in. Okay, so we're on to the last transistor that needs to be replaced here. As you can see, I got new ones in for the other 2. So the other 2 were kind of the round old flying saucer style. Both had these heat sinks attached. So trying to remember the orientation on those, pulling them out if I forgot making the video would have been difficult. But this one a bit easier because it's transistor shaped. Let's see if we can get it better. Yeah, this one with the yellow dot here. So I'll just show kind of how I take them out. So it's already desoldered, so just gonna get the camera where you guys can actually see what I'm doing. So again, just gonna clip the back of the legs, that way it pulls out nice and easy. So you can see the legs loose. Just trim them. Okay, so now I'm going to spin it. Just the camera. Okay, I'm going to make note of the orientation of the legs. So this one in the middle stepped up. The one on this side of the transistor, it's kind of in that middle hole, and the one on the opposite side is in the lower. Okay, so then we look at the board. So it came out again like this. So you can see the line there. So this one here on the end, that should be the base. It looks like there's the arrow on this lower one. So the one on the left here, that should be the emitter, and that leaves the collector in the center. So again, base, collector, emitter. And when we flip it, again, base is on the left. Base, collector, and then emitters on the end. Zoom out. We'll pop it in this component tester. And you can see lead 1, base, which is lead here, lead 2, collector, lead 3, emitter. So base, collector, emitter. And again, as we pulled it out, base was on this side of the board, so that's right. Collector was this one stepped up in the middle, and emitter. Okay, so marking on the board is correct to the transistor we pulled out. So on the ones on this board, I've been replacing with these, what are they? ZTX694B STZs. So these were recommended for this board by some of the pioneer gurus over at Audio Karma. Something to note with these is rather than your standard ECB configuration, base is actually in the middle, which kind of worked out well for the other ones because they were emitter base collector pinouts, or base. Yeah, the base was in the center. I can't remember which leg was which for the emitter and collector. But so for this last transistor, this is the only one that it won't work out kind of for. So let me check my notes. So what I usually do is I make note of the orientation of the pins. So side width routing, collector is the first, then base in the middle, then emitter. It's going to be tough to show on camera, but this is the side with the routing, and you can tell because it's the smaller side. Also drew it out like that, so kind of our smaller face. So we match up here. So this pin's collector, base, emitter. Okay, so base is in the center, collector we want up top, and emitter on the bottom, so it's going to be oriented this way. Base leg's going to step back a little, bend the lead back in, some pliers, and just drop it in. Okay, adjust the bend on the legs. Okay, 2 of the 3 want to go in. Okay, there we go. Okay, so that's in. Again, just tack these in quick. So as I was pulling one of these out, I did what I mentioned not to do, and I tried prying up on a lead that wasn't completely unsoldered. So that was this one. So the lead pulled up, or the can't recall the term, but the pad pulled up a little bit on it. There we go. So what I'm going to do is I just bent the lead over, and I'm just going to solder it up onto this to kind of skip over that little bit that pulled up. So again, nothing too fancy here. So let's get a good view while getting the camera out of my face so I can actually see what I'm doing. Okay, I usually find it easier to go bottom to top, so that's what I'll do. Okay, so on this one, we'll first just kind of get it that base there, and then just solder it up pretty nice, just to make sure that little bit of the pull bleed doesn't cause us an issue. Okay, that one looks fine. And again, on these, after I trim them, I'll just go back and give it a second tack to seal out any possible path of corrosion inside the leads here. Okay, so those all look in. Let me just get a little more on this guy down here. And I just made a boo-boo. So we jumped the solder between those two, so let's just get that cleaned up. So that would lead to a short, which is no fun. Okay, so that actually surprisingly looked like it worked. Usually I'll use a solder wick, but seeing I had that tool handy. Okay, looks like our jump is gone. Just trim these leads and give them that final bit of solder. Okay, so everything should be getting good. Okay, everything should be getting good, so let's just give it test again. Okay, so fired right up. You can see the bulb's not lit up, so didn't short anything. And we got some volume. Let's see, make sure it's at both channels.
We see here the term Son of God. If you knew that you was with him, made me shake his hand. We got that is reset. I'll tell you another thing that would not shock me.
Okay, so
back on a 1 year.
So far, so good. Haven't caused any new issues. Everything seems to be working as it should. So we'll move on to getting some new caps in that board. And we're back after maybe a week or so hiatus. Got a nice care package in from Mauser and DigiKey, so ready to start doing the recap on this thing. So again, we're going to start with this power supply board. Cap selection for this thing isn't too complicated. So power supply board, you're not going to have any signal coming through this. You're just pretty much supplying power for everywhere else. So your good power supply type caps, just really what you're going to want to use. So like a Nichicon UPW or UPM series or Panasonic FC series. So this board's got a couple different types of caps. So we got a couple 100 microfarad 50 volts, 220 microfarad 16 volt. I think these two back here are 220 at 25, and then the small 10 and 50. So just going to be using UPWs or UPMs everywhere, except for the smaller one. Nichicon discontinued what I was going to be using there, so just went with the Panasonic FC. So might end up cutting a bunch of this out, but basically just going to work bottom to top, desolder a cap, pull it, check the polarity. You can see here the negatives showing on these, and this one up here. Negatives are kind of facing down on these ones. So just going to check and confirm the polarity, and then just drop the new cap in. And then after all the new caps are in, just going to go back through and resolder. Okay, so that's the game plan. Just going to start resoldering these. Okay, so I didn't pre-mark these, so might be a little bit of guess and check here. We do have kind of the board layout, which is going to help me along, but yeah, we're just going to go for it, I guess. Just grabbing a scrap bag to eject all this pulled solder into. Okay, so that was the lower lead on that back cap. Okay, so that one's free. You can see the lead bouncing up and down, and I believe the other lead is up here. Yep. So let's do sort of that. And I guess I'll show this. The only kind of goofy thing with this desorter tool is after maybe one or two pulls, it gets kind of backed up, and when you press the plunger down again, you get this little ejected cylinder of solder that you got to pull out. So not maybe the best design for this, but it does remove it from the board well, so I'll deal with the inconvenience of having to empty it every shot or two. Okay, so we got both leads loose. You can see them both kind of dancing on the board, so we're just going to bend them straight. Okay, and I'm just gonna work it out. It does feel like there's a little bit. Okay, there we go. Here's our first remove cap. So like we thought, negative is on the bottom. It's a 220 microfarad, 25 volt. Okay, so what we're going to do is we're going to take our new cap. You can see this one here is, oops, grabbed the wrong bag. And that's why before you drop it in, you double check the capacitance on it to make sure you didn't make a mistake and grab the wrong thing. Okay, so let's try that again. So 220 at 35, 220 at 25. So when you're replacing these, it's important to keep the capacitance the same. And at minimum, you want to maintain the same voltage. It is acceptable to maybe go up a level or two in the voltage. You don't want to go from like a 25 to something like 150, but going up to a 35 or a 50 or even maybe a 63 should be fine from a 25 volt, but you really want to keep the capacitance the same. Okay, and as you can notice, the lead spacing on the new one is much tighter than what was on the old one. You can see that big bend. They even had to put in the old one to get it to stretch across and go through the two through holes. So what you want to do is you want to bend one of the leads out, then back in. You don't want to just take this and yank it. You can damage the seal on the inside here. So what I'll do is I'll take my pair of micro cutters, put it against the lead, maybe a millimeter or so above kind of the bottom plate, and bend out, and then bend back up. So I'll try to do this on camera, get it lined up. So just bend it out, and now you can just bend it back up with a pair of needle nose pliers or your hand or around the micro cutters again. So I'll just use the pliers here, make sure it's good. So I'll bend down, and then just guesstimate on where to come back up with it. So it won't sit completely flush to the board, but this is the best way I've found to try to not damage that seal. And just going from the wrong side to check the spacing, you can see it does go through. Okay, so we'll throw it in the proper side here. And again, negative was down, positive up. And we're just sliding it through. See if I can get this bend a little cleaner, so it sits a little flusher to the board. Okay, so it doesn't look bad. Let me take you guys over. So there's the new cap. You can see it's much smaller than the old one, but there it is sitting there. So I'm going to go around the board replacing these caps. The process is pretty much all the same, so probably pause the video now and check back in a little bit. Okay, and here's a good little tip for trying to get your components as flush as possible to the board. So I already got the bottom ones where I had to bend the lead in, so those are about as good as they're going to get. But these ones up here, these three in particular, you can see there, or these ones are actually pretty good. They fit pretty snug, but this one you can see is a little cockeye. So what you do, tack in one lead with a little bit of solder, and then once that's cooled and solid, reheat that joint, press on the top of the component, and then it'll straighten out. And then when you remove the heat, it'll solidify again, and then you'll be left with your square component. So you see it's a little off the board and not straight. We heat it, we can straighten it out. Now look, that looks much better. And then you just go back in, re-tack the joint you heated, or rather you do the one not tacked in first, then go back, and you can kind of continue on like that. Okay, and just to show that, so hit the joint that wasn't, and re-tack that, and then we'll do the same thing for these on top. Heat one joint and tack it in, press to make sure we're square. The back joint, same thing up here. Make sure it's square. Oops, sorry for the little bit of a ride there. And we'll get this last one. Okay, after this, just gonna trim the leads, hit them one more time with a little bit of solder to seal them in, and we should be ready to test to make sure we didn't make any bloopers. Okay, so we're back hooked up to the dim bulb tester. So let's give it a spin. Turn the unit on, and then hit the power on the dim bulb. Okay, so you see the bulb kind of heated up or lit up a little bit, faded, so no shorts. We didn't really do anything to the sound circuitry there, so nothing should change as far as the functionality for the audio, as long as it's getting power. Okay, so as you can see, we didn't do anything that made it blow up or short out, so we'll tack this board or screw this board back in and move on to the next one, which I believe is the main amp unit down here. So yeah, we'll get working on that. Moving on to the next board in the unit, we have the main amp board. I already removed the 4 screws and bent the board forward a little bit to access the back of the components to desolder. So on this board, we'll be doing a full recap and replacing these 2 transistors here in the center by the schematic. That is Q801 and 802. These are 2SC458s, which by the Audio Karma transistor list, these are known to go bad. So those are the 2 transistors we'll be pulling off this board. We'll be replacing them with KSC 1845s. So we'll start with those 2 transistors and then move on to the recap. Okay, iron's hot, and we'll just be following the same process as before. You can see I get the pins marked out with the black marker under here for our 2 transistors that we're pulling. So again, just applying heat and trying to clean that solder off. And then we can remove the component, check to make sure the pinout listed on the board actually matches the pinout of the transistor that was installed in there, and then we can go ahead and put in our new transistors. Okay, so let me try and find a better spot for the camera because I'm going to keep bumping this trying to get in there. Get to focus. Okay, maybe this is a little better, hopefully. Okay, so hopefully you guys get the idea. I'm just going to pause the video to get the camera out of the way because it's really kind of impeding my ability to really get in at this board. So once we're desoldered, I'll check back in and we'll go on from there. Okay, so they're both desoldered and pretty loose. So let's just pull the first one out here. Okay, so it came out kind of facing down and looking at it. Hopefully you can see the spot where it came out. So going left to right, we had base all the way on the left, collector, looks like the middle lead, step down, and then emitter all the way on the right. So here's our little C871. So it should go base, collector, emitter. Get our component tester, drop it in. Okay, and we're at NPN. Lead 1 is base, lead 2 is collector, lead 3 is emitter. So matches the board. Should just be able to substitute right in. I guess something to note, this 871 is not what was listed here on the service manual. You can see service manual listed a 458, but I believe these the 870s and 871s are still on the Audio Karma pull them out list. So let's get our new transistor in there. Again, we're using the KSC 1845 as the sub. pull some out of the bag here. Okay, and before we drop it in, just to confirm the pinout, we'll throw that on the little tester here as well. So we're base, collector, emitter. Kind of in reverse, so leg 3 is base, center collector, and emitter is on this end. And just to keep them straight in my head, I'll usually mark the base leg with the marker. That way when I'm putting it in, I have kind of a double confirmation that I'm putting it in correctly. So we'll just pull this out of the tester. We know leg 3 on this end's the base. And just quick mark on the leg. So I know that is in fact the base. And we can drop it in so we know the collector kind of steps down. And if I can find my pliers, just bend that lead and drop it in. Okay, so it's not going in easy, so kind of a trick is you can just go on the other side of the board where there's no components in the way. Try and put it in that direction just to make sure you got the leads spaced out right. And it looks like the stock spacing here is a little too far between emitter and base, so we'll just give those a small push together. And now drops through on this side, so we can go back to the component side of the board and install it where it goes. Again, black leg's base all the way at the end, and you see it just drops straight in. We can go behind here, bend one of the leads so it doesn't fall out, and good to go. So we'll repeat the process for this other transistor down here, get our new one in, and we'll be ready to solder in, test it out, and then move on to the recap. Okay, we're going to get going on the recap on this board. This is the W1591. So this is the main amp unit. So here's my kind of schematic here. So I've got marked out all the special caps on this board. So SP are those that looked to be in a signal path to me. So they'll get a audio grade or low leakage capacitor. BP, these are bipolar caps. So these are the ones that are really important that you pay attention to. Bipolar is either going to be replaced with bipolar or a film. So we're just going to work our way from the bottom to the top here. So this is just going to be desoldering, dropping in the new cap, and then resoldering everything on. So if this part of the video does not interest you, feel free to fast forward a bit. I already ran kind of the test of the receiver with the 2 new transistors in this board. Everything worked fine, so we're good to move on. I did not pre-mark the board this time around for the cap, so it's going to be a bit of kind of picking and checking, I guess. But with the schematic here, we should be able to do that pretty easily. Okay, so let's just get going on this. Got my favorite noise show on back here. So if you hear some cops in the background, it's not actually in my house. It's just the TV there. Okay, so these two resistors. So this should be the cap here. Okay, again, just checking to make sure I got the right lead, just giving the component on the board a little shake, and I can see the lead wiggling underneath. So we know that's at least got one of the correct ones there. See if we can get the second one out. Okay, and before we really pull it out, just going to note the polarity on it. So it looks like we got negative facing up on this one, or maybe I'm incorrect there. Stand corrected. Negative is down. Bottom, that matches what's on the schematic, and we'll see if that matches the screen printing on the board once I get it out. That leads good. Okay, this one should be ready or close to ready to come out. Okay, number one's loose and out, or loose anyway. This is marked on the schematic as 100 microfarad, 3 volt. Okay, negative was down. It is in fact 100 microfarad, 3 volt. So this was marked as being in the signal path. Where's my big old bag of caps? So use a audio quality cap. So what did I pull for that? So we've got a Nichicon UFW 100 microfarad at 25 volts. So just grab one of these guys. Pretty gold wrapper. If I can actually get it free from the tape. Okay, so negative was down. That's how the board was marked. Positive up. Okay, lead spacing. Might have to widen this one out. So following the same process as I used earlier, just bend in that positive lead around my micro cutters just to widen the stance a little bit. Okay, so positive up, negative down. Okay, drop it in. We'll bend the lead around the back, and that one is pretty set. just to double check. 100 microfarad, 25 volt. Acceptable substitute for this 100 microfarad, 3 volt. Okay, we'll put this back in the baggie for when we get to this guy on top, and we'll move on to the next one up. Which will be one of these on the front of the board here. Which one's gonna be tougher to take out with leads dangling in the way? Probably this one. Yeah, so we'll go for this smaller. Should be a 0.47 microfarad. Okay, so this one's a little trickier to find via the schematic. Okay, so something comes off pin 4. And bounces over. Bounces over. So could be this one. Something down here. Let's just take a stab. Okay, found it. So what you can do is just heat the lead on the underneath that you think could be it. When you see the solder kind of soften, you can work it back and forth. And if you can feel or see the lead moving with your eyes or just on the tip of the iron, that gives you a good indication that what you're shaking is actually attached to where the iron is. So it's a quick tip, I guess. Okay, keep going on with this. And this was the other lead. Yeah, quite the commotion going on the TV. Okay, so we got both these leads loose. It's 0.47 microfarad. We're gonna try to use a film in here if we can get it to fit. Usually anything under 3.3, I like to try to use a film cap to replace, just because they'll basically last forever. So we'll pull it. Note, negative was facing towards me. Okay, that looks like what was indicated on the screen printing. And on the board, or not the board, rather the schematic. Okay, so this is 0.47 microfarad at 50 volts. So let's grab our little film cap. .47 at 63. Double check on the actual cap itself. So for films, typically use either WEMA or K-MIT, whatever I can get cheaper. It seems like the K-MITs are cheaper at the smaller sizes, and the WEMAs are cheaper once you get above a microfarad or 2.2 microfarad. And the really nice thing about these is that they aren't polar, so you don't care about the polarity. You can just drop it in. Okay, look at that. So we are able to get that to squeeze in there. So on to the next one. So some people will just kind of decap the whole entire board and just drop all the new caps in. I prefer to go one at a time just so I can make sure that I'm putting the correct caps in the correct place. There's less, at least for me, there's less chance of making a mistake and dropping a cap in the wrong position because there's only one slot open. Okay, we'll do this bigger, 100 at 50 volt here next. Looks like negative is facing me. So we'll try and get this one undone. By the schematic, negative is facing me as well. So we'll just triple check here when we get this off the board. Okay, so from pin 9, it's the one all the way at the end. So kind of nice on this board, the pins are marked on the underside as well. Really don't want to bend the board all the way around, but yeah, let me just swing this over here. So you can see the writing kind of behind the pins there. So all the pins are marked, which is nice. Sometimes they're only marked on the top, which doesn't help when you're hunting under the board for something. Okay, so we got that one there. You can see is moving. And then this guy here on the bottom. Okay, so we have our two pins. We know where which through holes we're going to hit. Honestly, kind of impressed with this little suction tool here. Realize all you guys can kind of see it's my hand blocking, so we'll try to maybe get a better view here and try and get this thing up and out of the way so it's not directly in my way. But the last one of these I did the whole thing, all the desoldering with solder wick, which worked pretty well. I was using a cheaper braid, so took a little more time than I was hoping, and I used I don't know, probably close to a whole roll of it. So yeah, not the cheapest way to go about it. Just because of some of these boards, they globbed on the solder on some of these components. So and as I'm doing this, I'm realizing this is probably going to be a very, very long video. So maybe I'll cut some of this out or leave it all in, and you can skip as you'd like. Okay, both these feel loose. So we can try to bend these leads straight or just snip them right off. Okay, we're gonna try and work it out. Yeah, come on, let go. Okay, so it's out. Negative was facing me. Marked like that on the board. Check in the schematic. This was just a normal kind of cap, so we'll be throwing the UPW in there. So again, double check in 100. Yeah, it's not focusing, but trust me, it's a 100 UF at 50 volts. And our new cap. And for whatever reason, my camera does not want to focus. It's 100 at 63 volt. Negative's going to face towards me, so we can just drop that straight in. Bend one of these leads underneath, and that'll be good. Okay, on to the next one. We got these this black one and this blue one up front, so one of those two will be the next one. So the lower black one is 50 microfarad at 25 volt by the kind of board layout. It does look like the negative is on the bottom, which is how it's marked on that schematic layout. So we'll double check that. Okay, this one should be easy to find. It's just going to be these two pins here, or these two points here. This one, and should be somewhere down here. And here's one of those big just blobs of solder, trying to find where the lead is hiding out under here. Is there another component tied in here? Yeah, this VR. So that's probably why there's so much solder. VR probably's got a big chunky lead. Oh man, this one's a pain in the butt. Okay, let's see how loose this feels. Okay, the top one might be okay. Okay, see if we can straighten these out yet or not. That one doesn't feel like it wants to come. Okay, so I'm not making too much progress here with the little solder sucker, so breaking out the big guns and see what we can do with this solder braid. Okay, so this stuff is pretty easy to use. You just place the braid on the joint you're trying to desolder. Stick your iron on it, and as the solder heats up, if you got a pretty decent quality wick or a solder braid, the solder will start absorbing into the copper braid. See if I can see the silver solder kind of in the copper there. So it's kind of the best way I've found to desolder, especially something like this where the leads are all bent over and you're trying to get solder out from under stuff. And when it's kind of all covered in solder, you just snip it off with your cutters and move on to the next part of the roll. Okay, let's see how that works now. Okay, that one's good and free. And that one's good and free. Okay. So let's pull it. Okay, and we'll cheat because this one's not wanting to come out, so we'll just snip each of the leads short, and it should just drop right out pretty much. Okay, so negative was down. Got a 47 microfarad at 25 volt. And we'll drop in a 47 microfarad at 35 volt. This was another one I had marked as being in the signal path. So we got another pretty gold capacitor to put in there. .47 microfarad at 35 volt. This one's definitely going to need the lead bent. This was a little itty bitty cap compared to what came out. Okay, should have checked before, but I did say negative was down, and again, that's how the board's marked, so we'll negatively down. Bend the lead, hold it in, and move on to this next one. So this one is a bipolar capacitor, is blue one here. So that's not going to have any marking on it anywhere, and the board shouldn't be marked as being polar. So we'll move on to that. Interestingly enough, actually on the schematic, it's marked as polar on the layout, rather, but in the weird. That is really strange. Oops. Let me move you guys out of the way so I'm not just bouncing the camera stand every time I hit the plunger.
Are you dealing drugs? No. What's that white dusty substance on your paint lines there? Right there. See where my flashlight is? There's like a white crystalline substance on your pants. It does. You've been eating food. What food has white crystal substance on it? I don't see it. Well, that's the excuse I would use. I guess if I was 5 and I was. You have a warrant. Excuse me? I have a legal reason to be here. The fact that you're a vehicle parked in a parking lot with a closed business, and the neighbors called and said that they saw illegal drug activity. This is called a Terry stop. So I'm going to illegally detain you, to ID you, and investigate criminal activity that appears to be afoot. So whose radio is this?
Okay. So this one appears to be loose now. Let's pull it out and see what this is. Kind of a mystery cap here. Marked as polar on the board, but noted in the manual as non-polar. So we'll see what we actually have. Either way, probably drop a bipolar cap in here. Okay, so pull it. It is in fact marked NP, non-polar. But the silk screen on the board has a positive mark on the same side as what's on the board layout. So maybe it was a design change mid-run. Switch that to a non-polar cap. I don't know. It's just strange to me that both board and manual layout say non-polar or bipolar, while what's in there is, or I don't know, I got it backwards, I guess, but yeah, it's just strange. Bipolar in the device and in part of the service manual, and marked polar in other places. Okay, so here's our new cap, use ES series 47 or 4.7 microfarad, 25 volt. Unfortunately, I think Nichicon stopped making these little Mu series bipolar capacitors, so from here on out, where can't fit a film or where the film is pretty pricey, probably going to be switching over to Panasonic bipolar capacitors. From my reading, they have a pretty good audio quality one that's kind of similar to the Musi S series, so I'll be going with those in the future. Okay, so we got the black caps in the front here, and then around back there's two more grays in the back. So grab these ones in the back first, which it doesn't look like I highlighted on, oh, never mind. Okay, so these should be 10 microfarad at 15 volts. And these are should be right back here, kind of in this swoop. So it should be those two, and then these two for the one above it. Okay, let me put these caps back in the bag. So these might be a challenge to try and reach back with both the iron and maybe not too bad. Okay, so I think I said these two.
Now, how can you be sure you're getting the right deal? I have to talk to my dad, Steve. Hey, girl. This one's like your last boyfriend. It's got issues. Well, let's ask the experts. The right used car, just say, show me the Carfax value.
So, as you can see, there's nothing too difficult about going through and recapping a receiver, as long as you take your time, kind of get a method down to make sure that you're putting the right part in the right place. I go slow just to make sure I get everything right, but you could probably work through this receiver much faster than what I am right here. But this is just a hobby for me. I enjoy working on them, so I'm not in a rush to get through it, to move on to the next one to try and put bread on the table or anything. So take my time and enjoy the process as I'm doing it. Okay, got that one loose.
City Advantage Executive Card. The only card with Atlas Club membership elevates your travels. Earn Advantage miles and loyalty points, and enjoy premium benefits that heighten the experience. Travel on. City Advantage.
When you smell the amazing scent of David Greens,
Okay, and before we get in our own way with the new leads from the new cap, we'll just unsolder that one above it. Negative is facing away from me on both of them, just as what's marked on the layout. So we'll just go in and grab that next one up there. Okay, so these are kind of the same cap, one for each channel. Okay, let's see how that one's feeling. If it's loosey-goosey yet. A little bit of heat. That lead looks good. And okay, so both leads on that one look good. So already got my next project in the queue. I just picked up beat up Kenwood from a yard sale. It was apparently a barn find. Cosmetically, it's in a little rough shape, and did a little testing of it. Couldn't get anything on the right channel through the tuner. I tried the auxiliary input and didn't get anything from either channel, so that one's going to be an interesting project. See what's up with that. Probably try and do a video on that one as well. Might be a little more exciting than just watch me pop caps in and out. Okay, so both these out, both 10 microfarads at 25 volts. On the schematic, they were 10 at 15, but whatever. Okay, had these marked as being in the signal path. So I've got these UKL, low leakage Nichicons, 10 microfarad at 50 volt. So these should do just fine in there. And I said negative was towards the back. These might need a bend. Okay, negative towards the back.
With all vehicles and everything like that, especially how the uncle in the back, how he was acting. Is there any methamphetamines or anything like that I'm gonna find in the car? And who gave you the car? Is there actual name Breezy? Okay. Are you battling any addictions right now yourself? Good for you. Now let me ask you something, I'm not trying to downplay it at all. Is that because you were in prison or jail or anything?
Okay, both in. We can bend the lead. And these are all set. Okay, we'll probably do these two right here at the same time too, just because they're same exact cap, same orientation, negative towards me. You can see the negative mark. Again, just one for each channel. So we'll get those out. So maybe I'll do a video on cap selection at some point, but basic hint or some hints, anything that's low voltage rating, that is usually a good indicator that it's a audio path cap, or anything that is a really low capacitance rating, microfarad rating. That's another good indicator. They should be using an audio cap or a film. Okay, so that should be one of them. And so should go one. Where's the other lead? I guess this one. Yeah. So that's the top lead. Yeah, so the way they kind of bent some leads over each other makes it a bit of a pain to get some of this stuff out too. So a lot of stuff that's made a little later can be a bit easier to work on. As far as having straight leads, you can just kind of get a desoldering tool on and get it out. So I think that's the other lead. And the good part about the boards being more or less mirror copy, one half to the other, one side for each channel, is that once you find it on one side, you know right where to look on the other side for the kind of mirror component. Okay, looks like we finally got those two loose. Okay, so bottom one looking good, and we'll just grab this one on the top. Funny, for whatever reason, the top one put up much less of a fight getting disordered than the bottom one. Wish they both went that easy. Now let's see if they both come out easy. Now we're just gonna try to clip these leads right off. Okay, first one out. Second one's out. Okay, so these were 125. I didn't really have these marked as anything special or needing a audio quality cap, so the UPWs we used earlier. Should be fine for these. Okay, negative was towards me on both of them. Boom. Boom. Okay, what do we got left? 1, 2, 3, 4, 5. We got 5 caps left on the other side. Probably just gonna pause the video and get those done. Can check back in once they're all installed. Okay, new caps are in. I can see the board's nice and colorful now with all the green and gold caps in there. So let's give this thing a test run. Okay, power on and switch on the dim bulb. Okay, dim bulb goes out.
Entirely new next generation DIC.
Then we do have sound out of both channels.
With an undo button, because that's exactly
Go
what you're gonna
full
get.
left.
FanDuel Casinos. Play it again. I'm Bobby Smith, and this is why I love FanDuel Casino. You're getting up to
Full right.
$1,000 back if you're down after your first day. You can play your favorite table games on there.
Okay, yeah, so doesn't appear like we made any big mistakes on this board. Once we do the full recap, we'll come back through and adjust these resistors if needed. These control the rail voltages, I believe. So we'll go through and check that after the recap and all the parts are replaced. Then we'll also adjust the bias up here if needed. So yeah, onto the next board. So we'll either do the head amp board, which is the smaller one down here, or the control amp, which is this one up here. I don't know. We'll see which one will be easier to work on. So going to be moving on to the head amp board next. So a couple caps, a couple transistors to replace. So these in here are the 2SC7 or 871s and 870s according to the board schematic. So switching these out for KSC 1845s. On top of the transistors, you can see kind of that blue mark. So these were kind of matched from the factory. So going through my row of 1845s and just on the transistor tester, just checking the gain and going to try and pick out 2 pairs that are pretty closely matched, hopefully within HFE of maybe about 1 or 2. So gonna keep plugging away at this and hopefully get our match sets pretty quickly, and then can get into the board and replace them. Okay, we got all 4 transistors replaced. So they were all 871s, and then yeah, so I think all 4 were 871s on the board, or I'm sorry, schematic. I believe they were 871s and 870s. But anyway, so we got all the new transistors in. Started doing a couple of the smaller caps at the bottom. Nothing really special as far as this board goes. These big 100 microfarad caps here at the end are going to be your power caps, and the rest of these I believe are all signal caps. You can see 3 volt 100 microfarad, and a bunch of the smaller ones are 10 microfarad, 10 volts. So those will all get audio caps or low leakage caps. and yeah, big ones will become UPWs. So work through this and check in once I wrap this board up. Okay, we're on a final board that we're going to be working on here. Board's got 4 transistors, 2 on each side. Per the manual, these are 2SC 870s and 871s. Again, these will be replaced with KSC 1845s. We'll also go through and do the recap. Looks like we got a few. Now these are kind of grayish bipolar caps here. So these look pretty small, 0.22 microfarad. So probably stick some films in for those. Got a couple caps where some funky stuff's going on with the wrappers, so those probably aren't really that great anymore. So all of them are coming out anyway. So check back in once I get these transistors out, and we can move on with the recap on the board. Okay, so we got all 4 transistors replaced and in. Just fired it up. Radio was working fine, so now we're going to move on to recapping this board. Got my schematic marked out here. So as you can see, most of these caps I have marked as being in the sound path with the SP there. A bunch of these are smaller, under a microfarad or so, or at least a couple of the 0.22s you can see. We got some ones, it's 0.47, so those are all going to be replaced with films. We got kind of our power caps, which will be replaced with the UPW series, and the 50 at 15 and 33 at 6.3. I'll see what I have banging around for audio caps, maybe some UFWs or UKAs or something I'll dig out. So process will be the same, kind of replacing 1 at a time or 2 at a time. Checking polarity on the polar caps. We do have quite a few non-polar, and the ones that are being replaced with films, polarity doesn't matter. So I'll get working through this and maybe do a quick check-in in a couple minutes. Okay, we got the caps replaced on this board, so you can see I ended up going with a lot of films, a lot of audio quality caps. The only 2 that were, I guess, really standard caps are these brown UPWs at the end. Everything else was film, UKW, UKA, UKL, all the good stuff. So checked kind of the leads poking out, made sure nothing was touching or touching any of the solder traces on this board. So let's turn on the dim bulb.
Michelle, that's the contract we know everybody signed, right? The people who agree to perform and the people who buy tickets. The one contract that is sacrosanct is the contract you make with the people who invest in you.
Well, now that you brought up that little nugget about the contracts and that,
okay, so both channels are working. We don't have any shorts. None of the caps blew straight off the board. So let me just unplug it. So we're looking pretty good. Next step, we'll take care of these 2 filter caps as well as the 2 output caps here at the top. These ones are a bit tougher to deal with up here just because you got the 4 resistors there that you got to reattach and everything. So I'll probably do the filter caps first and then finish off with these 2 other output coupling caps up here. Okay, so I'll trim the leads and move on. Okay, before we do anything with the filter caps, we're going to make sure that they are discharged. So we can see right now, not too much voltage on them. We got like 30 millivolts or so. Just get one lead hooked up to the cap, other lead hooked up to the chassis for ground. These are, or the two positive leads on the filter caps are bridged with a wire. So what I'm going to do is just plug the unit back in. We can see the voltage increase as it powers up. I'll turn the unit off. We'll see it drain itself a little bit, and then I also have this filter or capacitor discharge tool. So what this is I forget, maybe a 200 ohm 5 or 10 watt resistor in here, covered with tons of heat shrink. Attached on one end, just have a brass rod that I grinded down to a point, and then the other end, just 600 volt rated alligator clamp. So that will get hooked to the chassis, and when I kind of hit the caps with it, you'll see the voltage on the cap drop. So let's just hook that up to the chassis right now and get this thing plugged in and powered on through the dim bulb. Okay, just power it on. Okay, so these are 100 volt caps. So we can see right now through the dim bulb charging up to about 83 volts. That's just annoying. That fuzziness on the radio, had to change that. So see we're settling around 83 volts here. Definitely enough to give you a solid shock that you really would probably rather not get. So we'll power the unit off, unplug it, and we can see that the cap's just draining through kind of the circuitry. And we'll add in this here as well, and you should see it drop even faster. Okay, so you see we're dipping into the tens of millivolts range. And again, this is discharging both capacitors because they're bridged, but we'll still kind of go one to the other. And we're down to like 20 millivolts, so these are pretty much discharged. Just kind of hit everything. Okay, so these should be safe to deal with now. So kind of move on to the next step here. Okay, so before I move on to removing the old caps here, clipping the wires, I marked the orientation of the existing capacitors. So these ones, the cap itself isn't marked with a kind of a negative lead like you'll often see on a more modern cap or on a lot of the kind of smaller ones that were removed. How you can tell positive and negative on these Pioneers is that the black, or the lead with the black dot, you can see on the bottom here, in both cases, so those black dots indicate the negative side of the cap, while the silver kind of lead base indicates positive. So I just sketched that onto the chassis with the marker. And while I was at it, I also did the coupling caps. These are a little bit tougher to see. It's a little dark back in there, but hopefully you can see that black dot on top of both of these. This one might be from the other side. Yeah, there you can see the black Black on that one there. And black on this one up here. So those are marked out. Now I'm just going to take some paper notes, just saying basically on these filter caps, red wires all tied to the positive side, black wires, resistor, and this other cap here all tied to the negative side, which is going to be on the bottom. So we'll just trim our wires here. Try to cut them as close to length as possible. Give yourself as much kind of space to work with. It is kind of difficult in some of these older Pioneers. They don't give a whole lot of extra slack. So if we need to, I might just add a little length of wire to the existing wire. Just make sure I can tie into everything properly. Okay, we got our new filter caps here. So the next step is going to be to make sure these are discharged before we start working with them. So again, the cap discharge tool, we'll just hit the leads with it for a couple seconds. Okay, something I just wanted to highlight here is the size differential between our new cap and our old caps. So these old caps are 1,000 microfarad at 100 volts. You can see these ones are 2,200 microfarad at 100 volts. And just look at how puny these new ones are compared to the old ones. Just pretty big size difference, and you can see the way the old ones are mounted. There is a bracket that kind of wraps around and squeezes on the cap to keep it in place. So what we're going to do is remove the old cap, remove it from the bracket, and then we have to add some chunk to this one just to get it to fit right in that bracket so it will stay in place. Well, let me give this a spin back. Okay, something else to note is look at the size of the leads on the old one. See, they're pretty large. It looks like they probably had a pretty large hole in it to wrap the wire around. And the new ones, we just have these two little metal legs, basically. I think this is a snap-in type cap, but it's going to be tough getting all that wire wrapped around this very well for soldering it in. So we do have a workaround for that. I'll show you in a minute. So let me get my parts. We'll prepare these caps first, then we'll snip out these ones and work on dropping these in. Okay, so we got those new filter caps prepared. So let's go through this step, snipping off the old wires and everything. So starting the one on the left here. So just basically going to snip all the connections off this one. Before you really go far into it, make a note where positive and negative were on the original and what the connections to each was. And the resistor. Okay, so this is detached electrically, so we're just gonna give this a spin. Okay, let me pull it forward. Okay, so hopefully you guys can see. We got the kind of the clamp part of it down here. What screws it to the chassis up here, and then there's like this lip that just uses leverage to hold that bracket in. So we're just gonna come in here with a Phillips head screwdriver, remove that top mounting screw. That's a flat one. Okay, I hid my screwdriver on myself, but we're back with it now. So again, just dropping in. Oops, excuse me there. Okay, it's undone, and then it just pulls right out. And again, just to show to sort of show what we're looking at here. That's the old one. That's the new one. It's kind of amazing how much the size of these have changed over the years. And this one's actually twice the rating of this one, 1,000 microfarad to 2,200, and it's about half the size. Okay, so now we got to remove the bracket from this one. So basically just loosen the screw. This one's a flathead. Again, before you do anything on these filter caps, you really want to make sure they're discharged. If this thing was charged up to its 80 or 100 volts that we were measuring on it earlier, and you put your fingers across these leads, you'd get a pretty nasty surprise. Okay, just putting my thumb over the nut on the other side so it's not just free spinning. And this is why I hate flatheads. Okay, see if that's loose enough, should be able to slide it off. So original filter cap's free, and you can see there's no way this thing is fitting in here without help. So yeah, let me go get some materials, and we can see if we can get this thing fit in pretty snug. Typically on these, what I would do is just wrap it with electrical tape, just a single band over and over and over and over and over on the lower part of the cap. But doing some reading online, it seems like there is maybe another better option. This is rubber foam weather stripping. So we're gonna give that a try today. So we're just gonna do a single layer at first, wrap it, and just see if that gives us enough diameter to fit snug. So this stuff it's got a sort of a tacky glue on both sides, so the electrical tape works fine. It just takes a while to get enough tape on this thing where it actually fits well. So this stuff might be easier. Just a single kind of strip of it. Okay, and put this over here. Now would you look at that? Done in 30 seconds rather than taking a little bit more time trying to wrap it in electrical tape. Okay, so let me just remove this kind of paper strip. Okay, this was mounted in this way. We know our negative terminal was down. Okay, so now let's just tighten it up to give it a good solid mounting. Wow, these flatheads are a pain in the ass. Well, let me try it this way. Let's tighten the nut. Sorry, I'm going to do this off camera. The screw is not cooperating here. Okay, so you can see this is securely in there. It shouldn't fall through or anything. So weather stripping was a success. Okay, now we'll just throw our newly mounted cap back in. Let me get the screw. And we're just going to try to line this back up correctly. You know what? I'm not quite sure I am super happy with the foam. I mean, it's on there, but it's kind of loose and wobbly when you touch the cap. Let me see if we put a second layer of the foam on there and we compress it down more, if that gives us a better seating cap in that mount there. So that's just a little too loose and wobbly for my liking. Okay, so we're going to loosen this again. Excuse my meter yelling at me over there for not touching it for 10 minutes. Okay, so I'm just loosening the bracket up. Let's see if we can compress the foam into the bracket here and see if that gives us a better, more solid seal rather than kind of the loosey-goosey floating I was just seeing. So just stuffing the insulation and cap in. So it's feeling better already. So looks like the trick is you want a couple layers of this foam and just spin the cap so it's facing the right direction. Yeah, negative down. Stuff the foam in here. And let's tighten this bracket back up. Okay, definitely a lot better. It's not as spongy, and this thing's not just bending straight out every time you tap it. So a couple layers of foam seems to be key. Okay, let's try and get it back in again. Okay, that's okay, so this would likely be a lot easier if I had this receiver flat, but I am going to still try to do it this way. Just because I like to make things difficult on myself sometimes. Okay, I think we got it. Okay, so just going to tighten that screw back in. Okay, that's in. And you can see the size difference again in these caps. Okay, let me spin this back around and we will get our wire connections into where they should be going. Okay, we're back after bumping the pause button. Again, just connecting everything up. So you can see still got insulation on the end here, so we're just going to take some wire strippers, try to remove a bit of this wire, or the insulation rather. Okay, I guess that's what we're getting off it. So again, just going to feed it through. Bend the wire over, and we got our connection. Okay, next wire is this one. Actually, gonna snip the end off this one. It looks like I cut it. I cut some solder with it, so I'm not gonna be able to strip the jacket off there. I don't know if it's just the size of this wire or what, but my stripper is not really getting a good grip on this stuff. See if I can just trim it off with the micro cutters. and I snip the wire. Okay, I do have another wire stripper. I'm not sure if there's enough room to use it in here though. Let's see if we can just burn some of the insulation off here. Not the best, my favorite option, but it might just be what we got to do. Yeah, I just have to clean my tip after this. Okay, looks like that should hopefully be enough length. We'll let that sit for a second before I touch it. Just kind of loop the resistor through. And let's see if I can push the wire and try and catch it under the resistor to hold it in place a little bit. As I kind of shortchange myself a bit, trimming the end of that wire off. Okay. Then here, nothing magic, just trying to get these things soldered onto the loops. So get the loop heated, get the wires heated, and apply solder. And now for the top wire. Okay, that looks pretty well connected. Sometimes these older wires do not like staying in place or being soldered in. In that case, you want to use a little solder flux just to really get them to grab. But everything here seems to have grabbed fine. And again, you can do a continuity check just to make sure it's all a loop. So on this one, we'll go resistor to end of the black wire here. And this one we can just check kind of pin to pin on the positive. Okay, so we are good. Can move on to number 2 over here. So again, snip this red wire, snip the black wire. Okay, on this side we got this capacitor. Okay, as part of my order, I didn't have a capacitor this style kind of the terms escaping me. Radial, yeah, whatever kind of the cap with the weeds coming out the ends is. Next Mauser order, I'll probably get some of those, and then just kind of dive back in this thing and replace this last cap. And then the two reds. Okay, so same process. Give her a spin. Unmount the old cap and drop in the new one. Looks like we are not on. So screws in kind of the same location, just upper right corner. Phillips head again, and just kind of keeping some pressure on the screw, so that way when it comes out, it doesn't just fall into the receiver, and it kind of stays in that bracket. Okay, I believe the last one I did had a Phillips head in the bracket as well, which is a bit nicer for me. I can never keep the screwdriver on a flathead screw. Okay, we'll just loosen this like all the way up. Slide it off the cap. Do another double layer on this thing. Kind of eyeballed it there, but looks like I might have gotten pretty close. Yeah, a little off. Okay, try and stuff it in. Negative wood down this way. Yeah, 2 layers is definitely the way to go. It looks like we got negative lined up pretty good. Okay, so it's going to sit in the receiver like this. So we'll tighten up the bottom screw. Okay, so Cameron just kind of crapped the bed there, so hopefully didn't lose too much of that, but basically we're just dropping the second cap into the mounting bracket with the foam rubber insulation. Okay, this one's looking pretty well mounted. Should be in solid enough. Okay, let's get this thing mounted up. That one went a little easier. Okay, just trying to get this thing to sit a little square in the bracket. Okay, that should be close enough. Okay, and twist it back around and make our connections on the bottom here. I don't know. I can't say that I am the biggest fan of this method, but maybe I'm just haven't worked out all the kinks yet. The tape seems to give me a more solid base on this. The foam's a little spongy, as I guess you might expect. It doesn't seem to really grip the caps super tightly. Okay, so we got first red wire. Let me just get you out of the way, and then we'll do the next two red wires. Come on now. Here we go. Okay, so we got at least a little bit of wire showing on all these. Connect them up to the positive terminal. So just feeding all these through the loop, or trying to anyway. We'll do the same for the negative on the bottom and get these sorted up. Okay, get all that stuff on top in, leaving that cap out of the way for now, just so I can get the positive ones a little better. And just try to make a good connection here. Okay, hopefully that's pretty decent. Okay, now for all the stuff on the negative terminal. Okay, do a continuity test again. Okay, so everything looks good on the negative. And where do these snake down to? Yeah, it feels pretty solid. Okay, so this filter cap seem hooked up pretty well, and let's just make sure that I didn't make any mistakes. So we'll throw it on the dim bulb, see what we get, and hopefully we don't have any shorts or blow the lid off these caps. See what that notes, it's in the right way, positive up top, negative on the bottom, but always do the dim bulb just to make sure. Okay, we got the dim bulb there in the back of this messy workstation. Make sure this is flipped on. I don't have the speakers hooked up, but you know, I can do that quick too. Yeah, most people hate this Pioneer speaker jacks, but not me. Compared to some other vintage style speaker connections, they are quick and easy once you get them on that speaker wire. Pull in and out, so nice for testing. It just sucks when you lose them. Okay, so we'll flip this on.
Going to the Ivy Legacy Foundation's annual Philly Men Are Cooking event. Oh, yeah. What are you cooking?
Okay, so both channels working, seems to be okay. So we'll move on to the coupling caps.
I did that once, yeah. I did it many years.
Next, so yeah. Okay, so now we're going to be working on these top output caps or coupling caps. So just going to trim away the resistors, and then there are some wire connections to each of the caps. We're going to take some notes on which wires go to which leg of each capacitor, trim those off, and then go ahead and put in our new cap. So let me get these resistors out of the way, and we can take a look at the wiring to each of them. Okay, we got those resistors snipped out. So you can see I already got the marking for the positive and negative sides. So we'll just go ahead and take notes on the wires, trim those out, and in tandem we will prepare the replacement caps, put those terminals on the end so that way we can get these things all hooked up. Okay, so it looks like we got I guess that's purple on the negative lead of the top cap, red and orange on the positive lead, black and white on the negative of the bottom, and blue and I guess that's a brown on that bottom positive lead there. So go ahead and make those notes and get these trimmed. Okay, so we've got the wires disconnected on the top one there. So give this a spin, and we'll pull that cap, mounted the same way with one of those brackets. So we'll just pull the screw out and get this capacitor out of here. Okay, so got the same kind of screw on here, so we'll just loosen that so we can pull the bracket off. Flathead again. And this one's spinning a bit more. And the old thumb trick doesn't seem to be working, so let me go get a small socket and throw that on there and get this thing undone. Yeah, it's not loose enough yet. Okay, we'll be back in a sec. Okay, we got our socket, little 5.5 millimeter, did the trick. Okay, pull the old cap out of the bracket, and just another size comparison, new versus old. New is same rating, 1000 microfarad, 50 volt, Nichicon KG series. So ended up going with these female connectors on the end here. Those resistor leads are a bit stiff, so rather than trying to thread them through the hole and bend it, it's easier just to shove it down in one of these connectors and crimp or just fill with solder. So doing that, but first we got to get the cap mounted well in this hole. We're in the bracket. I guess we'll try the weather stripping again, seeing I have it. So this is a much smaller bracket, so probably don't need quite as much weather stripping. Okay, let's see how that works. So this lip went that way. Screws on the bottom. And negative. Oh, let me just look at my little chart. Negative was on top. Okay, feels in there pretty firm. Doesn't need a twist or anything. So just checking to make sure that it should line up. Which looks like it will. So we should be good to tighten this down. Okay, feels in there pretty solid. So we're just gonna try mounting this back in here. And we're looking at the wrong caps on the camera. Sorry about that. So just trying to line up the bracket, the hole, and get in here with the screwdriver. And set you guys for a ride again. Okay, so first one's in. Let's give it a twist back around. Okay, and we'll just get everything kind of lined up. So what we're going to do is try to tuck the leads of the resistors in the respective connector. I'm going to trim some jacket off these wires so we have some bare wire to play with. So that purple was on the top, negative lead, and the orange and red here were on the positive lead. There's always got to be one, huh? But we do have a little bit more to play with on these, or a little more space, so I might just be able to use this one here. Okay, 14 was too big. Let's try 18. Let's see if that got a good cut through it. Unreal. Guess we'll just have to use this tool. Okay, got some off. Hopefully that's enough. Okay, so let me try and get this one all set up. Maybe I can do it on camera actually. So purple wire is in the top. Okay, so we got that one, that connector. See if we can get these resistors to drop in too. Okay, so that's in the both in the same part of the top. Okay, we'll do orange wire and the red wire. And the meter beeping at me. So thread that in. Okay, orange wire's in. Red wire is in. Yeah, let's see if we can get the resistor to drop in. Okay, what we might do on this one is fill that. Okay, so video dropped out there on me for a second, but we went ahead and soldered in everything for this top cap. So you can see on the this one, negative lead on top, we got the wire and the resistor kind of both in the same slot and just filled it up with solder. And on this lower one, just due to kind of how this resistor is sitting. It actually had to go in a different slot, but we got them in solid, not pulling out. Check the wires too. These are all solid, not wanting to come out, so everything seems to be connected up pretty well. Now we'll move on to this bottom cap. Going to be the same process as the top here, so might just skip showing that in video. Okay, so we got the lead and wire for the top negative connection here lined up. Not sorted in yet, so I'll do that quickly now. So as you can see, had to go with the lower hole for the wire and the upper for the resistor. So some of these old Pioneers, they didn't give you a ton of slack in the wire, so I was unable to get to that upper one with the wire. So I'm just gonna tack these in separate spots, which is fine. It's all electrically connected anyway, so it's not a big deal. Okay, so that one's in, and then we'll do the lead here. Okay, I think that both those should be good. We'll give it a bit of a test pull just to make sure that they are both in well, not gonna come loose. You can see it's in there solid. So we'll do the same thing here on the bottom. Put wires in one and see if we can get the resistor here to kind of reach the same spot. So let me put the resistor in, then I'll do this brown wire after. Okay, so that's in, and see if we can squeeze this other wire in here. Okay, feels like it's in. Looks like it's in. So tack all this stuff in. And sorry for the bump. Okay, so that looks like it's in pretty good too. You can see it kind of slightly bend in the terminal there, so I think everything is in pretty solid. Yeah, it looks good. And triple check my notes here. Brown and blue on the positive on the bottom, white and black on the negative above. And on the top one, orange and red on the positive lead on the bottom, and on the negative lead up top, purple and resistor. And we got everything lined up right. Positive here on bottom, negative, positive, negative. Okay, so this thing should be ready to roll here. So let me just turn off my iron. Give the camera a yank back. Let's see how we did. Plug it into the dim bulb. Make sure we didn't screw anything up. and we'll fire it up here. This side. Okay, receiver on. Okay, so no shorts, but no sound either. Looks like I bumped the speakers one too far. Let's try it on main speakers now.
Everything about people were communicating. I was too dark to run statewide.
Oh, please.
You know, I was too fast. You know, I'm always too something. But all I could be is too
Okay,
many.
just testing the balance here. That's full left.
Mm-hmm. And you too much.
That's full right.
Okay.
So both speakers are working. It was just that I had the speaker selector one extra over on the kind of B channel. So this thing is electrically repaired. We got all the caps replaced. We got all the suspect transistors out of there. So that'll probably be it for this video. Next, I'll kind of do the final steps. So we'll have the electrical adjustment. So we'll set the bias and make sure our rail voltages are good. And maybe I'll do a third video on this one, just cleaning the faceplate and the front glass. So this unit actually has a real glass panel in here. And from reading online, the lettering and numbering is very delicate. I've cleaned 2 of these completely successfully without kind of screwing up any of the lettering, so I'll show you guys how I do that. So just keep a lookout for the next couple videos, and see you guys later.